Hello everyone. This is day two of this training that is organized by the UK Data Service. So my name is Pierre Walteri. I work at the Training and User Support department of UKDS. Last time we ran a short presentation of the UKDS, but I'm assuming that the majority of you were also present day one, so I'm not going to run it again. But for those of you who are not present and who don't know very well who we are basically the main point of access for survey data in the UK. We curate most large-scale social surveys that are government funded or that are organized by academic organizations. On the one hand, so this data curation service, and then on the other, and this is where I'm talking or presenting from, a series of training content that we offer to our users, whether they are about survey data in general, about methods, or indeed about more specific type of data, such as time diary data. Okay. So that is the image I shared last time that is meant to represent the difficulty to capture with numbers the time. Uh, Before I start going through the content of today's course, I just wanted to remind you that if you haven't the data yet, you are advised to download it. So I'm assuming that everyone has signed up the license in order to be able to use the data. If you haven't the data set yet, so please download it using the link from Dropbox that is shared into the chat and try to install it on your computer so that in combination with RStudio, you will be able to follow the demonstrations I'm going to explain a little bit later. So by comparison or by contrast with last time, today we'll do more practical. So it's important if you're meaning to follow practicals that you set up your data and RStudio right now. So that's one thing. In terms of the material, so maybe I'm going to temporarily unshare my screen. In terms of the material, the slides I'm presenting and the uh, workbook that we will be following are all available on GitHub. So I'm sharing the link, or rather, uh, yes, so I need to unshare my screen temporarily. So here it is. So that's the link to both the slides and the workbook we'll be following for the practical later on. Okay, and now back to the slides. So hopefully this way you will be able to have all that you need, all the material you need to make the most of this course. Right. So last time we had a broad introduction to time use data. Where does it come from? Uh, what are time use surveys? What is the kind of things you can do with time use surveys? Today, we are going to go a little bit deeper in a number of important topics if you're really interested to do research with time diary data. So basically, there are four objectives to today's course. First, to make sure that you feel comfortable with computing time activity duration estimates. So we will go through another example. To understand the data quality issues that are specific to uh, time diary data, to understand the specificity of weight and data weighting in the context of time use estimates. And finally, compute this particular descriptive tool that are tempograms for time diary data. If you were not there last time, I think I've already hinted at that already. The course consists in presentations such as this one, and then code demonstrations. I am aiming to have sessions that are about an hour long with short breaks, and then we go to the next one. So practically, what we are going to do today is a short recap from what we've done last time for those of you who were not there, maybe to get a sense of what we are building on today. Then we go through immediately another practical session in which I will demonstrate an example of mode of travel using time diary data. Then we'll start looking at weighting and data quality issues. And after that, we'll have a presentation by a guest presenter who's Killian Mullen from Aston University. So he'll present some aspect and some research example about the context of activities. And then finally, the last session will be about computing tempograms. Right. So I am going to go through the recaps. So in a nutshell, uh, what is time diary data? So, and I'm talking really about the data rather than the survey tools. So typically, when you download time diary dataset, you will have several files most of the time, and you're most likely to find two kinds of files. So files that are similar to most survey files, so which are about individual sort of people and their characteristics that were interviewed in the survey. These may or may not come alongside what is called in some by some researcher aggregate files. So that are files that are not anymore about the people, but about days of observations. Uh, and sometimes they can be mixed together as well. So first of all, so individual or aggregate files where we have socio-demographic characteristics of respondent and maybe extra data about their days. And then the diary file. And the diary file is really what is specific to time diary data. There are different types of diary files, but the most common ones consist of episodes. So each line of data consists of an episode. What is an episode? An episode is a combination of the main component of time diaries, which is primary activity. What were you doing in the main? Secondary activity. What were you doing alongside your main activity? So let's say I was eating my dinner and I was checking my phone. Co-presence, who was there with you? Location, where were you? So these are really the core variables that are collected in time diary data. Sometimes alongside these come day level variables, so questions that were asked to people about their day. For example, was this day the day in which you filled the diary a typical day or not? And of course, in addition to this core content of time diaries, there are a number of variables that you will find in episode data set, sorry, that are essential in order to be able to work with the data, such as the start and the end time of an episode, uh, its duration, and of course, what I've just said above. Another version, which is less commonly found in time diary data, another version of diary files is what is called time slots. So instead of having episodes as the unit of observation, we have time slots, which is basically each time unit, each line of data represents a time unit, most of the time 10 or 15 minutes, uh, for which activities were recorded. These time units also can be thought of as the resolution of the time diary. So that's, in a nutshell, what diary files are about. And of course, uh, if you want to work with diary files, you need to do it separately and then combine it with the rest of the data in a second stage. I will come back to this in a moment. So that's the first thing. In terms of data structure, so uh, most or the most common time diary survey that you can look or access in the UK tend to be, like other surveys, household surveys. So which means that in terms of data structure, we have a four level structure. So we have household, in which one or several people may have been interviewed. So within people, or for each people that were interviewed, you then have days in which diaries or for which diaries were collected. And finally, for each diary, you have either the episodes that I've mentioned or the time slots. So that's a kind of fourfold data structure. And of course, that affects the way we work with the data. And maybe a last important point, in terms of file format, diaries can be, or diary files can be formatted either in long format. So as I said, each line is an episode, and which is the most common one. But also we can have another format that's called the wide format, in which lines of data are days, and then instead of having episodes as lines in the long form, like in the long format, each um, uh, characteristic of episodes are recorded as variable. So, for example, someone who has 25 episodes in its day will have 25 specific variables about their primary activity, secondary activity, etc., etc. It's a bit less common now that we have more powerful computers that can deal with time diary in long format. Okay, now in terms of how do we work with time diary data? So first of all, what do we typically estimate from uh, time diary data? Most commonly, it's about the duration of activities. So how many minutes, which is the most common unit of analysis, did you spend, or did people spend in doing things such as sleeping, working, traveling, etc., etc. Another big one is the probability of participation in activities. So since we are recording any activity by its duration. So it means we also have um, activities that have duration equal to zero, and that allows us to compute the probability of participation, as in whether or not people participated, and then average probabilities for the sample. And of course, we have most time use survey come with a detailed set of activities, but of course, depending on your research interest, you may want to group them in types of activities of various level of generality. When computing duration of activities, you are always, or researcher needs always to be mindful that there are two ways to go about it. Either you compute, you work with a full sample, and therefore you get durations that tend to be um, to reflect the existence of people who did not participate in the activity. So think of paid work, all the people who were on leave the day of the interview, or whether they were retired, etc., etc. So you have zeros, and these zeros are going to influence the value of the duration that you are trying to estimate. So, in other words, you either have everyone in the sample, but you need to take into account that the number reflect those who did not participate, or you restrict your sample to all those who participated only, so participant only, and then you will get a number that is much closer to the typical amount of time, the typical duration of activities. But that comes at the cost of the fact that for each different activity duration you estimate with participants only, the sample will be slightly different because obviously not everyone participates in the same set of activities. So in terms of workflow, uh, typically with time diary data, you can uh, use kind of ready-made aggregate variables, so durations that have already been computed by researcher that are provided with the individual or aggregate file in the dataset that you download. These are most of the time duration, so it's less likely to find a pre-computed probability of participation, or you can compute these all by yourself. So if you do that, I suggest a workflow here. There are other ways of doing the same, but that's the one that works for me. So typically you record the original time use activities in the episode dataset or the diary dataset, depending on how you want to call it. You sum the total time spent on these activities by person and day, and then you merge the data with the person level variable of interest you want to analyze these duration with. So for example, gender, age, etc. And then finally, you can compute the estimate of interest, such as mean time spent working or caring for children by gender. So that's really the basics of how to work with time diary data. Okay, so before going any further, so now I suggest that we go back to our studio, and I'm going to show another example of such estimation. So I am going to work with the uh, workbook, workbook day 2 that is available on GitHub. Uh, so here it is. So if you were not present in day 1, just a quick heads up. So we have all the syntax here that is that you're going to need to run this exercise. So either you want to go at your own pace and then and you don't you're not good at multitasking, so you can mute me and then do it at your own pace. I think we are going to take maybe 10-15 minutes to go through the first exercise. Or if you're good at multitasking, you can do it while listening to my own demonstration. So what I'm going to do, and I suggest you may want to do the same, is simply copy the syntax from the workbook here and run it in your own R Studio. So I am opening my R Studio session, and here we go. Okay, so first of all, a reminder, I think it was sent in the email by Emma a couple of days ago. So these are the library that we are going to need. Maybe Tidyr is not crucial, but dplayer, ggplot2, HMISC, and Haven are all important. So Haven to be able to get to import Stata or SPSS files, ggplot2 for the graphs, and dplayer for data management. So these are the directories in which the data is located on my computer. Obviously, you're going to need to adapt it to your own directories depending on where you have saved the data on your computer. So what I'm doing in this first line is to load these libraries and then to open the respectively the episode file. Uh, when you unzip the MTUS teaching dataset whose link was provided earlier, you can see that you have two files, the episode file, the individual file, and as well a code book or the list of the variables included. So I am opening this file. I am dropping a number of variables that are not going to be used this time, and I'm also leaving out the children here because obviously their time use fall out of what we are going to look at today. And finally, in the object that I call D, I am also opening the individual level file. So here we go. Takes a little bit of time to open the episode file because it's a big one. And as a reminder, again, if you were not present last time, the data comes from a sample or subsample of the Multinational Time Use Study, which is a large-scale harmonized database of time diary survey from all over the world. We have 5 countries here. Spain, France, the US, Netherlands, and the UK. And we can look at some interesting cross-country comparisons with it. So first thing here, I've opened the data, so I can just check that it's all well. Yes, I have my different objects. I can look at the size of the data set, for example, the episode file. So we have quite a large number of episodes, more than 1 million, and 20 variables. I can visualize the variables here. Okay, so you can feel free to use the head function or the view function from RStudio if you want to have a better look or a closer look at the data. We did that last time. I'm not going to repeat it this time. Okay, so as I said, what I would like to show today is how we can compute modes of travel and the duration by mode of travel. So in order to not to be confused between the country of analysis and the year in which the data was collected, I'm creating this variable. I will paste it in a moment into my RStudio that allows to uniquely identify studies rather than either country or the year where the diary data was collected, because some surveys had their data collected over 2 years. Okay, so uh, what I am going to do is what we did last week, which is uh, look at a specific kind of activity. Here we mean travel. And in MTUS, you can see that in the code book, the link is in the reference at the end of the slide. We can, this corresponds, travel corresponds to activities code ranging from 62 to 68. So that range from no activity recorded, but a mode of travel. I'll come back to this in a second. To traveling from to from work, traveling for childcare or for shopping, etc., etc. So we have all these different types of travel that we are just going to gather together in order to do our analysis. And then the mode of travel itself is contained in a variable that's called mtrav, and it has five categories: travel by car, public transport, walking, any other physical transport, or other unspecified transport. So we are going to combine these two bits of information. So the first thing we need to do is to flag in the episode dataset all the travel related variables so that we can use that flag to compute duration for travel as a whole later. So, we are doing this simultaneously as the mode of travel, because what I would like to do here is to compare the duration of travel by car versus travel by other means. So uh, I need to first run the study bit here. So that's what I said earlier with the study variable. Uh, so So just show the five studies I mentioned earlier. And now the tagging. So what this line of code does is define two variables, so TRCT and TROT, which identify respectively. So activities comprised between the two values 60 to 68, and respectively mode of travel equal to 1, which is travel by car, and between 2 and 5, which is other modes of travel. And each time such an activity is found, then their duration is allocated to the line to the variable, and otherwise it is set to 0. So that's what I call the tagging variable. And then next stage, we compute the total duration per person per day. I'm using, if you're familiar with the dplyr, I'm using the group by function. So I'm grouping the sum of these individual durations, or episode level durations, by obviously study, household, person within household, and days. ID is the variable that identify uniquely time diaries. Okay, so I'm just running all of this in one go. Okay, let's just check that it uh, be Okay, and if I look at the episode dataset, it has computed these four variables. Okay, next stage, we can visualize a little bit these estimates. So I can look at uh, what the distribution of these duration look like. And that's what we can see. Uh, so most of the duration of travel is inferior to 200 minutes, which is unsurprising. Most people, if you're familiar with the literature around travel, most people travel by car tend to travel for short durations, and you can get a sense of these durations here. And then we can do the same with um, yes, it's not correct to say mean. Actually, it's a distribution of days. Uh, with the other means of transport. And similarly, we can see the distribution, and they tend to be apparently shorter than uh, car journeys. Okay, so that's the first view of the data, but maybe we want to be a bit more precise and compute the actual means rather than just looking at the distribution of this daily amount of time. So I can do that easily using uh, other functions from deep layer. So here, what I'm doing, and I should have specified this earlier. Uh, Two things. You may have noticed that I'm using two conditions here. The first one is epnum equal to 1. Why do I do that? I'm doing that so that I'm actually, since I'm still working with the episode dataset, I'm doing that in order to make sure that I have one line of observation per day. Otherwise, we would be looking at all episodes that would bias our result. And the second thing is I've decided that I was only looking at participants, so people who actually did uh, do some travel on the diary day to have a better typical representation of the duration of travel. Okay, so now I'm computing the mean, and similarly, I am first looking at day level data, but I'm not adding a restriction on participant here. So overall, we can see that on average, people seem to be spending more time traveling by car rather than other means of transport. So 39 minutes of travel by car across all the countries that we have data about, and 22 minutes for other means of transport. I can go a little bit further and this time repeat the same analysis, but by maybe add two things. The first one is look at results by country, and the other one is also add the median value in case some of the durations are affected by extreme values. So that's what I'm doing here. So it's basically the same logic as before. So I'm starting again from the episode dataset, selecting only 1 day per observation. So episode first line of first episode. Um, group by the study variable I created earlier, and then create these four variables. So mean value or mean duration of transport by car and median by car, and then similarly mean duration by other means of transport and median duration. So that's what we get. So we get a first idea of the differences per country. Some countries have very or visibly longer average time spent by or transport by car, maybe unsurprisingly, the US, and that contrasts with shorter duration for most European countries. And conversely, uh, the duration of non-car transportation is higher in European countries, with some variation than in the US. You may also want to observe the significant difference between means and median, which means that uh, with the median being smaller in all cases than the mean, meaning that the duration in each country of travel is a little bit, or the mean duration is pushed by maybe a smaller number of participants who travel for a very long period of time. And then we have this intriguing result for Spain with median values of 0. I don't know if it's a problem with the data or something that is reflecting of people's way of life there. Um, okay, so I have done this for countries. Um, Yes, and of course, here we need to remind ourselves that what we are doing is estimating the probability of travel on a given day rather than the probability for respondent to travel. So we are working with day level data with so the populations are days rather than uh, people. So if I were now to look at the other kind of estimate we can compute with time diary data, which is the probability of participation in activity. Just here demonstrating how this can be done. It's quite straightforward. So we have, again, filtering on the first episode, in other words, daily data. We group by study as before, but instead of summing the duration, we compute the mean of this Boolean value, but it amounts to measuring the probability of these activities being greater than 0. So literally participation. And the last line here is a function that allows to round the result to 2 digits. And the result seemed to confirm some of the things we've seen before. So, in other words, these probabilities were reflected in the duration, the average duration that we saw before, because we had all the zeros that were taken into account for the computation of this mean. So, in other words, it's more likely, much more likely to be traveling by car if you're in the US. And there are differences between European countries, but these are by far not as large. The UK seems to be the country with the largest probability of traveling by car. And similarly, the probability of traveling by other means is also larger in Europe. And we have Spain here, which is the one with the largest such probability. Okay, so what are we doing here? Yes. So now I'm going to go quickly through this. We can go to the next stage, and instead of just looking at the basic characteristics of our episodes, just as we've done it, differentiating them by country, we can actually look at or cross-tabulate them with other variables of interest. So in order to do that, we need to merge the episode level data with the person or day level data that we have in the other data set. So and that's what I'm doing here. So I'm just using the basic merge command from R. I'm aware that there are other ones that you can use. But this one is intuitive. So I'm just merging the data. So in a new data set that I call DT. Oops. So that's the new data set. We can see that in this data set, we now have the variables from the episodes file that I've just created earlier. So the daily total of transport by car and transport by other means. So the next stage, the next stage is now to recreate, we did day one, explicit intuitive gender variable. The one in the data doesn't have a clear label, I think. So I'm just creating this variable. And then finally, we can look at estimates of journey by car and non-car by study as before, but also by gender. So by contrast with what we've done before, we are this time working with this new data set that contains the merged data. We group the data by study as before, but this time also by the gender variable. And maybe I can show you uh, this variable before use it. So that's what we are using. So as before, I'm creating a variable or column for uh, duration of car travel and another one for other means of transport, and also maybe a ratio variable to get a better sense of the difference between car versus non-car travel. And here we go with the results. So we can see that in most countries, in addition to the country level differences we've already observed, we have marked gender differences. Basically, women tend to travel for shorter duration than men by car, whereas the picture is not as clear for other means of transportation. So in other words, men who travel by car tend to do it for longer period of time than women. And when we are traveling, walking, public transport, etc., men and women seem to do it for the same or comparable amount of time. So just a small application demonstration of the kind of things we can look at with time diary data. And the ratio here shows you, yes, indeed, the ratio of non-car, car versus non-car. So the smaller the ratio, it means the less likely you are to, or the short, the more you travel by car relative to other means of transport. We can, but I'm not going to dwell on this to make sure I have the time for the other things I need to talk about. The next or the rest of the workbook or this section of the workbook shows how to do the same with participant-only data. There's a slight complication in the sense that since the participants differ from one activity to the other, we have to compute separately in other so separately for estimates for car travel and for other means of transport to make sure that we have valid results. So I'll let you do this in your own time or at home if you want to look at this further. So just to repeat, this was a way maybe to show other types of things we can look at with time diary data, and maybe if you're new to the if you were not present last time, to have a good overview of what we can how we compute estimates with time diary data. Okay, so I'm going to move back to the slides. Um, I think I was here. Okay, but maybe before I am going to ask if there are any questions in relation to what I've just presented. Uh, where is the Q&A? No, I don't see any question. If you have any question, really, please don't hesitate to ask them in the Q&A. I will regularly ask for questions. We'll have other opportunity later if you have any other questions that come to your mind. But feel free to ask anything that isn't clear or if you have any comments. Okay, so I'll move now to the next part of the, I need to share my screen again, actually, of the presentation. Okay, so I wanted to share a few words about statistical inference. So why am I talking about statistical inference? Have we not done statistical inference yet? And the brutal answer is no, because we have mostly described a sample. We have just looked at the data from the sample, and if we want to do statistical inference, to say things or to estimate things about the population, we need to do a few more things. So I left a slide here with a reminder of the essential of what you do when you collect survey data. So most of you will be familiar with it, but if you're not, then it's suffice to say that the reason why we collect survey data at random is that it has been demonstrated that this is a valid way of collecting and being able to compute estimates, unbiased estimates from population and through getting a representative sample. At the same time, in the practice of collecting survey data or collecting a sample, there is unfortunately some bias which come from some people belonging to specific groups that are less likely to be sampled. And among those that are, in addition and or among these, you also have people who are less likely to take part to sample, to survey as well. So to maybe give a caricature, if you're a young man under 25 and you live in a city, you are significantly less likely to take part or to be interested in taking part to a survey and to be sampled than if you are an old lady who live in a small town or even the countryside. Uh, this state of affair is known, so that's why surveys, especially in the UK, use sampling techniques such as stratification and clustering in order to deal with these. Stratifications is a set of techniques that allow to recruit more respondents from groups that we know are less likely to be represented in the sample. So typically group defined by gender, age, ethnicity, etc. And clustering is something that allows to cut the sampling cost or the cost of gathering data by restricting the drawing of the sample to a smaller number of area than the whole population. Okay, so why does that matter? Because if you want to compute estimates that are really robustly representative of your population, you need to take into account of the characteristics of your sample. And you do it by doing two kind of things. First of all, by weighting your estimate. So you're not just, as we have done so far, um, computing means or proportion by just working with the value in the data. We also need to weigh these estimates. Uh, and the influence of weights depends on the type of variable that you look at, the size of the subpopulation, etc., etc. It's the difference between weighted and unweighted may be large or small depending on the characteristic of the survey. And the second things we need to take into account when estimating survey data or estimating population characteristics from survey data is what's called the survey design variables. Basically, variables that allow you to identify clusters and the strata that were used when collecting the data. And these are important because these allow to get a proper sense of the precision of your point estimates. Um, so typically that are to have a realistic confidence interval of standard error. Unfortunately, survey design variables are not often available in data. So which means we always need to be mindful of the limitation of the precision of the point estimates we compute from survey data. Okay, so that's in a nutshell. When we work with time use surveys, we have an extra layer of complexity. So remember, our populations are not people or not only people, they are days of people. And these may correspond, for example, in the case of the UK Time Use Survey of 2014-15, days over a full year. So days of UK people in UK household throughout 2014 and 15. Uh, what we want from the point of view of time diary analysis, we want to make sure that the data and our estimates reflect or give an equal probability of selection of days within the week and months within the year, so that we can indeed make inference about what happens within a full year rather than some part of this year. And one of the problems is that if everyone was doing what they were told, which is collect their diary on their randomly allocated diary day by the interviewer, things should be okay. But most of the time, people don't always do what they're told because they are too busy on diary day, whatever the reason. So we end up with an unequal distribution of days. And for that reason, we need to compute diary weights. which are basically re-establishing an equal probability of or adjust the frequencies of days and months in order to make them as equal to each other as possible. So, just to make sure the vocabulary is not confusing, when we mean diary weight here, we don't mean a separate variable that we need to apply separately from the weight. We need the sampling weight. We mean an extra layer of weighting that is added to, or rather multiplied, because this we multiply different categories of weights together. So to the traditional survey weights. So the diary weights are survey weights times non the diary weight. Um, And something else that we need to be mindful of is that unfortunately for budget reason, not all time diary data have been collected throughout a full year. So that's the first thing. And therefore, it's not, we need to be careful when we make generalization or when we make statement from estimates we compute, that we are mindful of the time of the year they relate to: summer, winter, which time, which month of the year, etc. The second thing is, unfortunately, again, given the cost of data collection, um, most time use survey collect only 2 days of data per person. So which means that it's not very well suited to look at, to examine differences between people in detail. So we can, and there's a lot of scope to examine the difference of uh, time people spend on days, uh, but we are not really being able to look very robustly and differences between people. Okay, so there's another set of things we need to be mindful of when working with data, time diary data. So not everyone is zealous when completing their time diary. So it's sometimes necessary to look at how many episodes have been recorded by people, and we may want to drop some low quality diaries where people usually have recorded fewer than 7 episodes. There can be missing episode, incoherent time diary. This is due to the fact that until very recently, most time diaries were collected or filled in by hand. It's a little bit less common now that we have electronic instruments such as apps to collect time diary data. Also, there can be gaps in the time diary, etc. So there's a number of techniques, and if I have the time, I will demonstrate some later on that can help identify diaries with a small number of episodes or with total duration that doesn't add up to the 1440 minutes that makes a day, etc. Okay, so I am going to maybe for 10 minutes go back to the workbook. The workbook is here actually. Okay, so back to the workbook. Why um, workbook? Because I want to show a couple of things in relation to weighting. So the first section of the weighting and data quality uh, part title, um, simply shows the effect of weighting the data with time with diary weight. So if we start again with the MTUS data here, I can simply start by looking at the distribution of days per country. So this is what this command here does. So at the core, we have X tabs, which is basically cross tabulation. So I'm cross tabulating country and day of the week. Uh, and that is for the day level date set. The other two functions here compute proportions and run them and convert them into percent here. So what we can see is that we have clearly certain days, and that differs by country, certain days that are less likely to be than others to be, or rather, days on which the time diary are less likely to have been completed. So we want to remediate to that, and using the diary weight from MTUS, which is called prop WT, we can remediate to that. So a quick and dirty way of weighting cross-tabulated data without using a specific survey command is to add it on the left-hand side of your formula within Xtabs. So that acts like a weight. If you don't believe me, you can check it up online. So when I apply weights to this cross tab, we can see immediately the significant difference. Now, most most studies have an equal probability of representing each day of the week. There are few differences, but most of the time these probability are equal. So that's simply to show how important it is if you want to have estimates that are representative equally in the same measure of all days of the week to use these weights. Unfortunately, given the heterogeneity in the samples and the studies that are part of MTUS, the same is not true of months. So if I keep using the prop WT MTOS diary weight and I tabulate the month of the year by study, I can see there are really significant differences. So if you want to have studies that are representative of a full year, then you have to unfortunately limit your analysis to those surveys that collected the data around a full calendar year. The UK 2014 and 15 studies did that. I don't know about the UK study for 2021 onwards. I should check that. Or alternatively, you need to make sure that you signpost readers of your research results to the fact that your results are only representative for such and such time of the year. Okay. There is a way, so I'm not going to expand too much on this, but just to demonstrate what I've just said, I have provided the example of waiting also for month of the year, but this time using indeed the UK Time Use Survey of 2014 and 15. So this data is not available to you. Uh, Sorry, but if you're based in the UK or affiliated with a UK institution, you can download the data from the UK Data Service and reproduce this yourself. So I'm basically here doing the same thing as I've done with the rest of with the MTUS data. So I am looking at the diary data from UKDS, we had downloaded from UKDS and Time Use Survey 2014 and 15. I'm selecting the diary or opening the diary data in wide format because that gives me access to day level data. It's easier. Diary day act is the diary day on which uh, uh, the day on which the diary was effectively filled in. And I am doing the same exercise here using dia WTA for diary weight. And I can see that as with MTUS prob WT, it equalizes the number of, the probability of each day of the week, but it goes further. And if I compare now months of the year, I can see that once I apply the weight, as here, we have an equal probability of selection or an equalized probability of having data from each month of the year. Okay, so just maybe health advice that you should use weights, diary weights when working with time diary data. Okay, now moving on, I also need to say a few words about, especially for those of you who are not entirely familiar with using weights in your daily statistical analysis, how to do that with time diary data. So there are two schools of thought. So the first school of thought and that's the one that is really the correct one, which is when you compute estimates from survey data, you should use the functions from your software package, whether it's R, Stata, SPSS, or SAS, functions that are specially designed for working with survey data. So why we do that? Because even if you don't have all the information such as survey design variable that would allow you to use the full features of this survey function, they give you a range of options, such as straightforward access to confidence interval, and in the case of some software package, you can be sure that the estimates and the confidence interval are computed the right way. For example, it is well known that with some types of weight, SPSS goes a little bit crazy and computes completely wrong estimates. So that's in the case of grossing weights. So here I'm just going to demonstrate or to show quickly how you can compute the same kind of estimates of activity duration as before, but using survey specific functions in R. So I'm going back to my R studio here. So you need to have the survey package installed, and you install it the same way as any R package. So install package, install.package, and then survey. So its logic is similar to the way you work with survey data in Stata, for those of you who are used to working with Stata. So first of all, you design a survey design object. So with the SVY design object, and then you apply the estimation functions to this survey design object. So you can also see that survey design object is a survey design informed version of your data set. So here I'm creating a new object, a survey design object that I'm calling DS from the DT merged person episode dataset that I created before, and I'm specifying the main parameter. So here, this is where you are supposed to specify the clusters or primary sampling unit for those of you who are familiar with it. And here I'm just putting one because MTUS is one of these surveys where we only have weights and we don't have survey design variables. So we don't, it's another way of saying that to R that we don't have a survey design variable. So strata, uh, we don't actually have strata information for the surveys that are included in MTUS. But on the other hand, I consider it as good practice to conceptualize the country of such a multi-level, multi-country study as strata, given that the sample proportions were different from one country to the other. So study or country and year of data collection by as strata, and most importantly, weights here probability. You will notice that, and that's a little bit different from other R command, any parameter, even if it comes after an equal sign, need to be specified after a tilde. If you forget about the tilde, you will get an error message. So I'm just specifying, creating this object. If you want, you can have a look at the object. It's not really human friendly to read. What is it? Yeah, I can't use summary, then I have to use ls. So it gives you the component of the object, and can you, yeah. Um, I'll leave you to the documentation of the survey package if you want to explore this a little bit more. Okay, but now the core of estimation. So here we are using a new command that's called SVY by. So SVY by is simply a command that allows you to compute uh, certain estimates. So here SVY mean, so survey design or survey data specific computation of mean, but it could be median or it could be a proportion. Uh, and we are using SVY by when we want to estimate the statistics for given subgroups. There are a number of potential trap when estimating survey data for subpopulations. I'm not going to dwell into that. So it's also called domain estimation, and using SVY by or the equivalent in Stata if you work with Stata allows you to not fall into such traps. So SVY by for these combination of gender and study. The first parameter is actually the quantity I want to estimate. So here, mean duration of travel by car. So duration of travel by car, the mean here is the statistics I want. And you also may want to estimate or to specify the way or the form in which the variance is going to be displayed, whether confidence intervals, CI here, or standard errors. And finally, as before, the last line is about rounding the results. So here I am just running this, and we have our results. So, as you can see, the main difference in the output in what with what we had before when we computed means without the weights is that now we have nice confidence intervals that give us maybe a better idea of the precision of those estimates. And we have in the first column here, after the year, the proper computation or the proper, more robust point estimate of duration of travel by car. Uh, so I'm going back to the slide here. Something you may be interested in doing is, and I'm not dwelling on this, but I've done the same for respectively travel by other means by car. So you can see the corresponding results here. And I've also done it for participants only. So the main difference when you run it or when you do this for participants, you need to redefine your survey design object so that it only takes these data into account. And uh, this is especially important because when you change something, define a subgroup, etc., the SVY design object is not updated automatically. So each time you change something to your data, create a new variable, etc., you need to create a new survey design object. Okay, I'll let you run that in your own time if you are uh, interested. What I want to show though is to briefly compare these with what we did earlier, so the unweighted one. So if I, for example, take as a point of reference a gender difference for the US result, so we have 57-47, and I'm moving up to the first section. I think it was somewhere like here. Yeah. So we can see that there clearly is a difference. So we are moving from 47-57 to 53-44. It's not huge, clearly, but it's definitely there. And it is the case that if we were to look at more specific subgroup, smaller subgroup or specific subgroup of the population, it's highly likely that these would move significantly. And it's also the case that when you look at data set like that, it's also very important to get a sense of the precision of your estimates and therefore to also be aware that in some cases your confidence interval can be quite wide. Okay, so I have covered most of what I wanted to cover uh, about using weights and survey design. So I'm going to stop here because we have already worked for a significant bit of time. So I'm going to first ask if there are any questions. Feel free to ask them in the chat or in the Q&A. Maybe there are already questions in the Q&A that I haven't seen. No questions. Okay. Yes, there was a question about yeah, no, the time use survey is available under under EUL, so safeguard the data. You don't need a special, you don't need to apply it for control data. Yes, for inference, you need always to use the weight. That's true of any survey, but that's particularly true of time use survey. All right, so it's 27 past 2, so let's start again. Before giving the floor to Killian, I just want to say two more things. I've demonstrated how to compute means using survey functions. The equivalent function for computing proportion would be using the survey package, a function that's called SVY_prop. So that you would simply need to change with SVY mean in your SVY by command. But the survey package documentation is quite easy to go through. So that's the first thing. And the second thing is, to the person who asked about whether using weights for inference. So most of the time, this is the case, and this was the spirit of my answer earlier. But there are a smaller number of cases where if you do statistical modeling rather than computing uni or bivariate estimates, some people use another approach to inference or controlling for sample design by using what's called model-based inference. But that's far beyond what we are doing today. And this is something maybe you need to really know what you're doing if you were to use that. Okay, so enough of me for now. So I am now giving the floor to Killian. So Killian is a lecturer at Aston University, but I'm sure he's able to introduce himself much better than I would do. So please, Killian, go ahead.
Good afternoon, everyone. I hope you can hear me. I'm gonna tilt so I don't need to hear myself in the headphones. Um, so I hope you can hear me okay, but do let me know in the chat if you can't. Yeah, my name is Killian. As Pierre said, I am a lecturer in sociology at Aston University, and I'm very pleased to be able to join you this afternoon and talk a little bit about my research using time use data. So let me just, I'll actually, let me share my screen. Let's do this. Cool. Can everyone see that all right?
I can see your screen. Can you switch to, are you on full screen?
Sorry?
Are you on full screen?
Do I need to be on full screen?
That's nicer.
Okay. All right, cool. Let me do that. How does that
Yeah,
look?
that's better. Thank you.
All right, cool, cool, cool. All right. So the main title of my talk is actually the subtitle. So it's activities in context in time use research. So hopefully that will be clear as we progress throughout the chat. I'll keep an eye on Q&A, and again, if you have any questions in chat or you want to stop me at any point, please do. It won't bother me in the slightest. So as Pierre has been explaining very carefully, the analysis of time spent in different activities throughout the day is very much the backbone of time use research. I mean, the vast majority of time use research is primarily concerned with time spent in different activities. But this data about activities can be enhanced by putting it in context. And contextual data in and of themselves can be a source of much that is interesting to know about how we spend our time. So, mainly when we think about time use research, we think about categories like work, leisure, and work includes, paid work, but also unpaid work. We might think about the gender division of paid work and unpaid work. But we can really deepen our analysis or add layers to that if we also bring into the picture information about context. And so, as I say, that can sort of supplement information about activities, but also it can stand on its own and be interesting from a research perspective. And I'll give some examples of that. Just very little about me. I hate talking about myself, but I started working with time use data. I sat down to do these slides, and it made me think about my life. And I've been doing time use research in one form or another since 2003, which is a long time. Um, so I do have a lot of experience working with these data and doing research with these data. And I hope to give you a bit of a sweeping tour of that in the next 20 minutes or so. The main focus of my research is really looking at how children spend time, but again, locating children in families. And so thinking about children, thinking about parents, so how do parents spend time, how do children spend time? Broadly, I'd say I'm interested in sort of the family and sort of time use in the family. And so that takes, coming into that is obviously parents and children, and that's been the main focus of my research. So thinking about children's time use, I've been interested in questions around how that's changed over time, how it's impacted by parents, how it's been impacted by technology, and that obviously links to questions about change. And I'm also interested in sort of more methodological questions about the measurement of aspects of the context of daily life. And in particular, the measurement of sort of time with children and time using devices. So I have had along the way things to say about both of those things. All right. This isn't like everything I've done, but this is mainly what I'm going to talk about today, or I'll talk about it a good bit. So what is context, right? What do I mean by context in daily time use? Okay, well, you've already covered this already, right? So I don't think there'll be much that's new here. But it's really, like it's the places where you're engaging activities. It's like, the location, the different places, whether you're at home, at work, in a restaurant, in a library, in a park. And the modes of travel. Are you on a bus? Are you on a train? Are you in a car? Are you walking? I guess now if we have like new time use surveys, we'll have to add like e-scooter or something to this list of possible modes of transport. Also the people you're with, right? So this has been absolutely fundamental to my research, asking questions about, our parents with children, our children with parents, and so on. But that also includes time when you're alone, right? So being alone is also information about the social context of your day. So latterly, time using devices has emerged as a kind of an ambiguous aspect of time use. In one sense, it's an activity. If I use my phone, I have my phone in my hand, I'm using it. That's an activity, right? But because of the way in which devices, especially mobile devices, have become really embedded in our lives, almost to the point where we're often not even aware of them, and they serve as a sort of platform for a range of other activities. And I'll show you a little bit of that with respect to children. It's in that sense that I much prefer to think of them as kind of an aspect of the context of daily life, but it's ambiguous for sure. I'm sort of limiting this to what I know is generally in the data, but I am curious about other aspects of daily life, daily time use that we might think about as being a part of the context of our activities. And I won't put anyone on the spot, but if you have any thoughts on that, you can just throw them into the chat at any time. There are some things I can think about, but it's interesting to think about it and then think about, oh, how could we incorporate that into a diary instrument? And then think about the kinds of questions that we could ask if we had that data. So how is it captured in time use surveys? I'll do this very quickly because Pierre has already done this in great depth, but sort of running parallel to fields in time diaries that collect data on main and sometimes secondary activities. These instruments often ask a number of questions capturing contextual information. So they will ask, where were you, right? If you were traveling, what was the mode of travel? Who were you with, right? ATUS is an acronym for the American Time Use Survey. They have a very specific question about childcare, like was a child in your care, that they're trying to get at something of the context of daily life that's very specifically oriented to the care of children. And I'll come back to that in a little bit. And lastly, where you're using a device, for example, a smartphone or a tablet. So these are standalone questions, and they're relatively, they're not incredibly onerous to fill in. Okay, and if you'll have seen the UK instruments, I think Pierre will have shown you, but you can pay attention. I want you to be very mindful as you begin to explore time use survey to look beyond the activities and to go, oh, is there anything interesting in the context? Questions that I could bring into to enrich my analysis of activity. So why is context important? This is sort of one of those questions, once you write it down, it's almost like, well, I mean, of course it's important. Context is everything. I might have wanted to say something deep and meaningful here, but I think the best way to answer this question is to kind of look at the kinds of research questions and research topics that we can examine by using contextual data. So one of the most important, and it certainly occupied a lot of my time in my sort of early years of doing time research, is thinking about how we measure time caring for children. So that's been a subject of much debate, and I'll show you in a few slides how context data has been absolutely crucial in building, in sort of capturing the full extent of time that parents spend caring for children. I'm going to show you a little bit of research where I've been using contextual data to analyze the impact of maternal employment on children's time use. And these 2 points are interconnected in that the sort of questions about measuring time caring for children are absolutely integral to questions about analyzing the impact of maternal employment on children's daily lives. I would argue that it gives you, bringing context into the picture gives us a multi-layered, a deeper, if I might say, understanding of change in children's time use. And lastly, it's been incredibly important for me in terms of exploring the impact of digital devices in children's daily lives. And I could sort of just, maybe not points 1 and 2, but certainly points 3 and 4, I think we can apply those to adults. We can apply those to any person in our sample, not just children. So, question, how much time do parents spend caring for children? You've done a time use survey course. You might be thinking about looking at time use data. To answer this question, and if you looked at the activities, that's going to give you one part of the answer, right? So this has been a core question in time use research. Scholars are definitely interested in tracking change over time, tracking gender differences, and the impact of other factors such as education and parenting norms. Now, if you know, the conclusions that you draw about any of this, may or may not be affected by the extent of the way in which you're measuring childcare. So getting a full comprehensive measure of childcare is very important in terms of properly answering these and other questions. So focusing only on care recorded as a primary activity provides a very limited measure. I mean, I'd suggest if there are any parents in the room, I'm not, but speak to any parent and ask them, is the time that you're specifically providing care to children as your main activity, is that it? Is that all it is? And they will tell you emphatically, no, it is not it. There is much more to it than that. And so it's incumbent on us as researchers looking at time use to take that into consideration. Adding secondary activities is better for sure, but they are burdensome. They are prone to prompt bias. Some surveys mention childcare, some surveys don't, and that matters. That seems to affect the way in which people use that field. And actually, you know, it's still an activity-based measure. And if we think about childcare, yes, activity focused, directed activity is an important part of it, but it's not the only part of it. And we need to also think about the supervisory care, the kind of the mindful care that is happening. So using contextual information about whether or not a parent is co-present with the child provides a much more complete account of the total time that parents spend caring for children. And that seems like such an obvious thing to say, but there are some people who disagree with this. There are some people who say, well, if it's not your main activity and you're doing something else, then you're not doing childcare. And there's a debate to be had there. But I'm definitely on the side that says that there is much more. The temporal constraints of children extend beyond the time that you are recording doing specific childcare activities. There are, from surveys to survey, and when you're looking at contextual data across surveys, you have to be mindful of the different ways in which that information is collected in diary instruments. So there are variations in the way in which co-presence is measured from surveys. So some surveys may restrict it to being in the same room. Some may not. Some may say who was doing this activity with you, right? So that's a much more restricted definition. So in terms of measuring childcare, in work I've done with Lynn Craig, we were basically arguing that you need an expansive measure. You need a measure that isn't restricted to being in the same room, because supervision can happen when children are, you know, children can be playing in one room while you're doing something else in another room, and you are supervising them, and the space is actually doing some work there. So it was important, we argued, that you needed a contextual measure that wasn't restricted to being in the same room. And just to go back to what they do in the American Time Use Survey, they actually created a bespoke contextual field, and people were asked, was a child in your care during this time? And you know, they did a lot of work on this phrase "in your care," right? And they wanted to ensure that people didn't restrict their responses to time when the child was in the same room. So bringing information about context is absolutely crucial to addressing any question about using time use data to answer any question about parental child care, if you want to say something comprehensive about that. Okay, so this has been a really important question, like what impact has increasing maternal employment had on childcare time? And it's a loaded question, it's a divisive question. Some people arguing it's been detrimental, others arguing it hasn't. And time use researchers have been keen to get involved in this debate and to show, actually, sort of to show convincingly that maternal employment has had very limited impact on the time they spend caring for children. And it's really concentrated in this sort of contextual time, right? This sort of supervisory care. And using contextual data, using time co-present with children was absolutely crucial to showing this, because, it would have been silly to say, well, it has no effect at all, right? But actually bringing together information about activities and context was absolutely crucial in terms of building up a complete picture. So then I've done some work then looking at the effect that increasing maternal employment has had on children's activities, how children spend time. And, building on this idea that context is really important in terms of understanding parental time caring for children, I argued that it was absolutely crucial. If we wanted to ask this question about maternal employment, we had to understand how it affected who children spent time with, as well as what they were doing. If you wanted a complete picture, if you just looked at what they were doing, you would get an incomplete picture. You needed to, it's almost like this two-step process. You needed to first understand how mother's employment changed the social context of their day in terms of who they were with, and then look at how their time and activities in these different contexts. So to do that, I was bringing together data on who children were with, along with data on about what they were doing. So I was bringing together these two fields simultaneously, and I was able to show that children with full-time employed mothers, they spent less time with their mothers, but they spent more time with their fathers, right? So we saw this shift from spending time less time with mothers, more time with fathers. And then I was able to kind of go, okay, and then when they're with their fathers, they're spending more time watching TV, right? So the social context, and specifically understood here in terms of like which parent are they with, sort of influence what they were doing, right? So I think if you were to just look at the activities on their own, you would come away with that going, mothers work, children more time TV, right? So it'd be quite a simplified and I think partial picture, right? But if you see actually what's changing is the social context of their day, and then within that, what they're doing. So, all right, and so then I've been looking quite a lot about children's change in children's time use. I think you'll get access to these slides, but this is a link to a book that I won't take you to. And I was really, obviously there was a focus on activities here, but also like I was really interested in location. And partly the focus on location here was mainly because the data from the 70s didn't have a lot of great context information. And the bit of context that I could harmonize really effectively across this span of time was whether or not children were at home or not. And that was interesting because there was a huge debate about, are children spending less time outside? Are they spending more time indoors? And so I was able to kind of address that question as well as looking at changes in children's time use. So I was basically able to construct a set of measures looking at changes in activities when at home and when outside the home. And, I did find a substantial shift towards spending more time in activities at home with substantially less time in unstructured leisure outside the home. And the argument here is a slightly subtle one. In a way, I used context to organize the activities, because the activities, some went up, some went down, some stayed the same. But actually, when you brought context into the picture, that actually helped to organize what was going on, right? Because the bigger picture here was that there was a shift toward the home. So there's a shift away from spending time outside the home and a shift toward the home. And that obviously shaped then the changes in the activities based on that. So then in research, more recently, I was looking at time using devices. Obviously, there's huge debates about screen time, ongoing debates. When I was doing this research now, it's quite a few years ago, and the debate certainly moved on. But at that time, there was a huge amount of concern just simply about the amount of time, right? And so that's what I was kind of interested in using, time use data to get at that question. And what was really critical about time use surveys was this recognition that device use is concurrent with time and other activities. So most of the research out there was using recall-based questions, like how much time do you spend using your device? Very unreliable. But the perception is, you get, children are spending 3 hours using devices. And the sort of the unspoken assumption was that they're not doing anything else. So then they must be doing less of other things. And actually, we could use time use data to scrutinize that idea. And so what I was able to show is that children spend a substantial amount of time using devices, for sure, but it was alongside time in other screen-based activities. And there was very little evidence to suggest that other activities were compromised in any way. I'm just going to escape out of this and just, can you see this table? I hope.
Yeah.
Yes, we can see it.
Did someone speak there?
Yeah, we can see it.
We can see it, yeah.
Okay, cool. So, this is just the total time in 2000. This is the total time in 2015. And then this is time using devices in 2015. And then each row here, so I have TV, primary activity. So in 2000, they were spending about 2 hours, 20 minutes. In 2015, that had dropped to just under 2 hours. And for about a half an hour of that time, they were using devices. So they were saying, I'm watching TV, but they were also saying, I'm using a device, right? We couldn't say if they were using a device to watch TV or if they were doing another activity with the device, but we could just observe, right, that a half hour of time using devices ran alongside time when they were watching TV. And similarly, we had computers as a main activity, video games as a main activity. So actually, if you kind of run along all of this, you kind of get an hour and a half of all time using devices is when they're doing another screen-based activity. And then we have this hour and 16 minutes of time when they're using a device doing other activities. So you can see this total, it's 2 hours, 45 minutes. And you go, okay, yeah, that's a big number. That's a lot of time, right? But what we were able to do with the data is to just break that down and to just show, actually, this is running alongside time in lots of different activities. And then if I go back here, I hope this works. Where's my graph? I'm in the wrong. Am I here? Yeah, you were able to just kind of observe then that, they're using a device when at school, when socializing, when traveling, studying. So all of these activities that children are doing in their daily lives, that the device use was kind of embedded in that activity. So it wasn't like this kind of, if you look at the total time, it's a lot of time, but what we were able to show is how that was woven alongside time and a whole range of other activities. And actually, I was able to, this is some work in comparing the UK and the US. And you can see that, you've got time watching TV, and the lighter shade here is time using devices when watching TV, time using devices when doing video games. And you can see how device use, it's concentrated in other sort of conventional screen-based activities. But it's it's spread across a wide range of different activities. So it's not as if children are not spending time in the activities that they have always been spending time in. It's just that the use of devices has become a part of that. And I'm not saying whether that's a good or a bad thing. There's a whole load of other questions here, but I think it was quite useful to just, in a nutshell, put device use in context, right? In the context of daily life. So that's what that was about. Is this going to work? And then the link for the UK-US comparison. And then in other work with Stella, I was using kind of co-presence, location, device use data, basically everything, right, that was there, right, to really build quite a detailed picture of how the context of children's daily life had changed between 2000 and 2015, which crudely is a sort of before and after, sort of, well, before and during the explosion in the proliferation of mobile devices. And really, what we found there was that there was this really quite significant increase in the time that children said they were alone, right? But we didn't just stop there, right? Because we looked at where they were, right? So, and we didn't just stop there. We looked at where their parents were. So we brought in contextual data from parents, children. So we were able to kind of co-locate children and parents at the same place at home, right? And so what we sort of observed was this really significant increase in the time that children stated they were alone, but they were at home when their parents were also at home. And so we used this phrase that was out there in the world already, this sort of alone together. And if I show you here, you can see that, you know, there was this really quite pronounced increase in the time that, if I make this slightly bigger, in the time that children said they were alone during this alone together time. So, and that was quite, you know, we argued that was quite an important sort of shift in the way, I guess, families spent time together. And, you know, for nearly all of this time, you know, children were using devices, right? So this was a really, you know, and this is a really kind of like important finding, I think, for our research at this point, but in terms of highlighting this, but it wouldn't have been possible, right, to sort of even get at this if you just looked at activities, right? If you just looked at what children were doing as their main activity. You absolutely had to look at activity for sure, but you had to look at all the aspects of context, and also you had to bring together the data from parents and children, and that's also quite an important thing to do. And in surveys where you have household level data, that's quite an important thing to do. All right. Let me just go here. All right. So basically, you know, what am I saying? Activities, they take place in context, and that's important. It's important for you to look at that. And sometimes actually context is really interesting in and of itself. I would say time use research can be enhanced by incorporating contextual data into measures of time use, right? So when you're thinking about constructing a measure of time use for analysis, you want to be asking yourself, can I deepen this if I bring some information about context, right? In what way can I get at a richer kind of question? And so you can look at contextual data on its own, and you can look at it in combination with activities. But it's about, when you're thinking about constructing measures of time use for analysis, I would strongly encourage you to look at activities, but also look at the information about context, and where possible, try and combine that. And that's all. That's about half an hour I got there. Thank you very much. I think there's about 10 minutes for questions if anyone has any questions. And I'll share these slides somehow, and the links to the various sources are there. Cool. Thank you very much.
Thank you, Killian. That was really interesting. Are there any questions? Feel free to ask them either directly or by putting them in the Q&A box. Yeah, this was really interesting for me as well, because the time spent with children was not my specialty. So I've learned a few things here. Maybe if no one asks question, I could ask something. And sorry if it's the silly question, but has there been studies that have looked at for children the time spent or association between the time spent on device and the time spent sleeping?
There has. There's quite a bit of research on that, and um, it's a while now since I looked at that work. But I think I was gonna do a bit of work with someone, and it never really materialized because most of that research was using recall-based measures, and they did generally find an association, like a negative association, and but there hasn't been a huge amount using time use data. Part of the issue, it's a pity. I think you could do an interesting question, an interesting piece of work with the data we have, because the device use is part of the context. So there hasn't, as far as I'm aware, been a huge amount of research using time use data answering that question, but there has been quite a bit of research on that question.
Okay, thank you. I think there's a question. So someone is asking if you're aware of qualitative studies looking at the time spent by children or with
Yeah,
children.
there's a huge amount of um, qualitative research out there for sure. Um, uh, yeah, for sure. It's probably the majority, actually. Um, I was making an argument that we could do with some quantitative data. Someone's asked me about my theoretical framework.
Yes, exactly. I was going
Um,
to.
I don't know if I have a theoretical framework, if I'm being perfectly frank. Um, my, I try, I mean, I, my approach to looking at children's time use is really to not overburden it with a theoretical framework. To just sort of let the data say what the data is going to say. These are records from children, their activities. My approach has always been, we're saying a lot about children, we're saying a lot about what's happening to them, we're saying a lot about how their lives are changing, but there hasn't been we really need to just let the data about children speak for itself. If that can be considered a theoretical framework, then that's it. But I'm certainly not coming. Do you have anything in mind, Gabrielle? I'm not really coming at this from with any strong sort of theoretical argument. I mean, yeah. I don't know if that answers Gabrielle's question. It doesn't really.
But I suppose what we can add, what I could add to this is maybe part of what I presented last week, which is uh, there are a number of theoretical assumptions that are implicit in working with time diary data that I mean, it's quite basic, but it has an impact on what you can do when you're looking, for example, at children. So that time is something objective, that it is limited, and that is the same for everyone. Now, you could argue that you can also look at subjective time, for example, and that wouldn't be possible, of course, with time diary study. So in that sense, there's at least for anyone who's working time diary data some theoretical constraints or an implicit theoretical framework.
No,
Uh,
it's always something I've struggled with in terms of there aren't if I look at because I looked a lot at the sociology of childhood and theories of childhood, and for me, the idea of children's agency was something that I kind of held on to a lot in terms of but it doesn't strike me as a theory as such. It's more of a statement of how you see the world, or sort of validating children as reliable kind of respondents, really. And listen, if you were doing a qualitative study, you talk about listening to their voices, right? I still think that's a phrase you can use in quantitative research with quantitative data. It's just that the nature of the data, the character of the data is different. But I certainly, in terms of a study of childhood, I was definitely very keen to emphasize the importance of recognizing children's agency. But I'm not coming at it from a feminist perspective. I'm not coming at it from a critical race perspective. There's a little bit in there about class, about socioeconomic issues. I was very keen to foreground gender differences always. Yeah. I'm curious if Gabriella has anything to come back to on me on that. Is there anything that you're thinking of in particular that I should be paying attention to? Thank you. All right. Cool, cool, cool. I think you're on mute, Pierre.
Yes, actually, that's true. So I just want to say, if you have any further comment for Killian after this, feel free to
Oh,
put
I
it in
should
the
put.
chat and we can relay. Or Killian, if you want to share your email address,
Yeah, sorry,
everyone has.
I should have put that on the slide actually. Cool.
Okay. So
Cool.
again, sorry. Thank you again, Killian. That was really, really interesting. And I hope we will have you again next time we run this course.
Cool,
Uh,
cool, cool.
and yes, so
Thank you very
see.
much. I've got to shoot off, so I'm gonna leave, okay? Enjoy the rest of the course.
Okay. See you. Yeah. Okay, so in the 45 minutes that we have left, I want to spend time maybe focusing on two things, or maybe two and a half. I want to say a few things and demonstrate how to work with tempograms, which is a really nice illustrative tool to describe time diary data. And then in the process, I will say a few things about a specific type of time diary data that is really interesting for those who work with paid work or full-time education, which is a work schedule. And then I would like also to, towards the end maybe of the session, to talk a little bit about more advanced things that you can do with time diary data. Okay, so I'll just switch back to my slides. Okay, tempograms. So far we have described activities and episodes with mostly duration and probability of occurrence. Of course, Kilian has also mentioned context. But there's also another way of exploiting the richness, so to speak, of time diary data. We can, for example, look at the distribution of activities throughout the day. So, for example, the proportion of people doing certain thing at certain time of the day, or before, or the kind of activities that are more likely to take place depending on which portion of the day we are looking for. So that's about the scheduling of activity, but we could also look at the sequencing. How do they come together, or the ordering? What comes first? So these are the slightly more advanced concepts, but that are also equally important or interesting for research. So that's an example of tempogram. So what does it represent? And I think I showed a version of this last week. So on the x-axis, we have time of the day. Remember, time use surveys tend arbitrarily to start at 4 a.m. and finish at 3:59. We have activities that are, maybe I should go to full screen, activities that are um, divided or organized in 8 groups. So sleep and self-care, work and education, reproductive work. So that's anything that is self-care, eating, etc. Shopping in this case, caring for the people, volunteering, physical activity, leisure, and other. So that's 8 roughly representative of 8 activities or 8 group of activities that are roughly representative of what we mostly do on a typical day. And then for each time of the day, and that's really granular, we are looking at each time slot, 10-minute time slot. We can look at the proportion of people engaged in each one of these activities. You can think of these as a really granular succession of cumulative bar plots, if you want. So what does it shows? So it shows, for example, a large area, a large proportion of people working or being in full-time education between 7 a.m. or 8 a.m. and 6 p.m., no surprise here. And conversely, larger proportion of people engaged in leisure activity as we move past 6 a.m. For example, the pink range here is for sleep. So most people sleep between 10 p.m. and 7 a.m. And yes, childcare, reproductive work tend to happen throughout the day. There's always a small proportion of people doing reproductive work at any time until maybe 10 o'clock. So that's the kind of insight you can get from looking at tempograms. So, but here it's a really still general type of information. We are looking at men here, but in weekdays, but we could go down further if the data allows for it. If you have enough observation, we could look at men's of a certain age, men of a certain in certain occupation, etc., etc. So how do we create tempograms? So in order to create tempograms, we need time slot data, so which is either in long or wide format. So as I've just seen, the tempograms are organized with 24 hours that we have in a day, split into 144 time slots. So that's assuming that the resolution of the diary is 10 minutes, but it's most of the time 10 minutes. And then on the y-axis, we have the proportion of people engaged in each kind of activity. So in terms of the steps to create tempograms, we will see that in the practical session in a little while. We want to first record the activities into the group of interest. There's 8 here, but there can be more or less depending on what you're interested in. So we then compute at each time slot the proportion of respondents in each group of activity. And then we plot it using an area plot. So that's for if we use a ggplot2. And then the example I'll show later is by doing it gender and day of the week. Basically the same kind of plot in the previous as in the previous slide. So that's the kind of result we are going to be able to look at. So without going into too much detail, so the plot on the left-hand side is the one I showed earlier. So men on weekdays, but if you look on the right-hand side, men at the weekend, you can notice that the area occupied by paid work has shrunk significantly. There's more time spent on reproductive work and shopping. People and men as well shop more at the weekend, and leisure activities, unsurprisingly. And if we look at women, uh, also interesting results. So of course, women do paid work, do more paid work at the weekend. Sorry, do more paid work on weekdays than at the weekend. But comparing with men, you can see that the area is smaller because women work part-time. There even, or some women do not do paid work because they are looking after dependent person, children or adult. And conversely, women do more reproductive work. If you look at the green area, um, than men, and more caring as well. There's nothing new here, but that's an interesting way of visualizing it. And interestingly as well, uh, when you look at the weekend for men and women do more reproductive work still at the weekend and a little bit less leisure activities than men. Okay, so that's a broad overview of tempograms. But now, before going to the practical, I want to say a few words about special type of time use data that is in also has a bearing on time on temporams. So far we've seen that time diaries are about collecting information about a lot of activities on 2 days typically per week, one day at the weekend, one day, one weekday. But there's a number of surveys, unfortunately, fewer now, that have been collecting a special tool called the work schedule. And what is a work schedule? It is basically a photography of a full working week, which, if you're into research on flexible, atypical work, is really something precious. So, by comparison with normal time diaries, and this picture shows it here. People were simply asked to draw a line on the part of the day that was spent either in paid work or full-time education. So we end with the data set. So it's part of a mainstream time use study. So it's not a specific survey. But in addition to the main diary, the 2-day diary, people were asked to fill in this work schedule. So we end up with and that's the 7 week. Sorry, I don't think it shows very well, but it's just an illustration of what people were asked to fill in for a full week. So you just draw a line or bits of line corresponding to the time of each day in which you were doing paid work. So they were part of the Harmonized European Time Use Survey guidances until 2018. So we have such data for a number of EU countries, including the UK. They were collected in 2000 and 2015. Yes, so that's really an innovative and interesting tool for studying work, paid work. So here, and that's the connection with tempogram. You can, of course, plot paid work across each day of the week if you have work schedule data. I don't have the time to demonstrate really a working example of drawing tempograms for work schedule data, but just to give you a foretaste or a taste of what we can do. So here, as the slides show, It's for everyone. If we were going to look at men versus women, we would already have differences in the in these hills, so to speak, hills of paid work. So we can see across the day, obviously, that people tend to work between most of the time 7-ish, 8 and 7 7 in the morning, 7 in the evening. We have lunch break around lunchtime. These do not vary very much for the first day of the week and slightly different for Friday, and also markedly different for the weekend. So that's, of course, a little bit trivial here. But again, once you start looking at subgroup of people, that's becoming more interesting. Okay, so now I'm going to move back to the workbook. Um, I think my workbook is here. Yes. And I would like now to take you step by step, or to work step by step, and build a tempogram. So I am not showing the practical for data quality inspection here. You can do it in your own time. And also we are going to use some of these tools for preparing the data for the work schedules. So it's mostly about looking at the maximum number, so the total number of episodes per day, um, and dropping bad quality, so to speak, data diary. Okay, so now back to the work schedule. So a number of considerations. So I wanted in this example to show you that a real life example, basically. So the MTUS data that we have been working with is not sanitized, so to speak, teaching data set. It is the real MTUS data, and as such, it has some problem with some diaries in some countries. So, for example, the data that we have for the Netherlands, unfortunately, and for what was the USA, have problems that I'm not discussing them here, but I'm leaving them out for computing these tempograms. And what I'm doing in this first line of data here is looking at the study, and of course for each day, so each diary day. So again, grouping the data by study, household, respondent, and diary. I'm looking at the minimum number uh, of episode. What I mean by that, no, the minimum episode number. So EPNUM, if you remember, is the sequential number of of each episode in a typical diary day, ranging from one to whichever how many episode the respondent filled in. Which means that if we compute the minimum of such number, we are able to check whether an episode or a diary day started with episode number one. Unfortunately, there are sometimes bugs in the data, and we have episodes that don't start at episode number one. So we want to make sure that we don't have such data, otherwise we are going to run into trouble when computing our tempograms. And conversely, we want to make sure that the larger the total number of episodes here is realistic. So it's not too small or not too large. We want to also to check whether the total time, and here we are using the time variable, which is the duration in minutes of activities for each episode. no, for each episode, sorry, I'm getting confused. So it's the measure of each episode. We want to sum this to make sure that it all adds up to 1440. And finally, end is the end time of each episode. We want to make sure that the largest end time, which has to be 1440, because this is the end of our 24 hours day of observation, is indeed 1440. And if we do that, if each one range within the value we are expecting, then we can go ahead and we can be assured that the data is suitable for drawing tempograms. So I'm going to paste this syntax here. So as I say, I'm only keeping French, UK, and Spanish data. I'm computing these indicators of data quality. And then I'm creating, so this data set, I'm calling it, or data frame, I'm calling it ep.m. And I'm adding to it also data from the individual data set with some of the weights and the study variable that we created earlier. And we use this to match observations. Okay, so just to get an idea of data quality issues. So most of the data that we have behaves as is expected. So have the starting episode number being 1, but we can see that we have a non-negligible number of observations that have starting episode number different from that. So we can inspect and spend a significant amount of time looking at how to correct for that. And sometimes these can be corrected by just filling in blanks in the data, but it's beyond today's topic. So what I'm just doing here is give you an overview of things that are untowards in time use study. And we are just going in some time use surveys, and we will be simply dropping later on these problematic observation. So if I look at the yes, I can compute that as a proportion of the total number of observation. And you can see that even if some of these numbers look quite big, actually in proportion of the total number of episodes per country, it's actually quite small. So it's not too bad. So similarly here, I'm inspecting the sum time, which is the total amount of time. So looking at mean, median, it seems fine, but we have indication that we have some observation for some countries that are not what they should be. And indeed, if I compute the proportion of observation, here I'm using a conditional statement with observation, sorry, the proportion of observation with time diaries ending up as expected with 14 and 40 minutes. We can see that no, for example, in Spain, only 77% such time diaries are present. It's even lower in France, and hooray, the UK data set are slightly better because we have 84% of diaries that are properly adding up to 1440. And then conversely, we can look, we can inspect further also the last or the ending time in terms of cumulative minutes of the last episode. And in some studies, it isn't 440, whereas it should be. So just to give you an illustration of the kind of issues you can find in time diary data. And when you are writing a paper and doing something that is going to be subject to scrutiny, obviously you want to make sure that you're working with data that has the required quality standard. So here we will be dropping all these strange values. So I am doing it here. I need to add that, so the first line of the comment here, so that's filtering observations or diaries that do not add up to 1440 or do not have an end time for the last activity, the last episode that is 1440. But also, I am in the process converting this episode dataset into a time slot dataset. Why am I doing that? Because if you remember, we want to do a tempogram, and with tempograms, we need time slot to have proportions of involvement in each activity that match each 10 minutes slot of the day. So we can just check that the data behaves as it should be in the new time slot data set. And it looks like it is as we should expect. So we have for each household person and diary time slot here. And of course, we may want to check that the maximum number of time slots which I have created with the syntax here matches 144. Remember, we have 144 10 minutes time slot. And I can do that quickly here. All the observations or have add up to 144 time slot. Okay, and yes, and just in case you had any doubt, you could also look at that by country. Okay, so that's for the data cleaning part of the exercise. Now I am going to start working on the tempogram per se. So I am aware that if you're only moderately familiar with R or with statistical modeling, so this may sound a little bit complex. So I'll try to be not too fast, but also you will have feel free to experiment with that at home or in your own time, and I'm sure it will become straightforward after a while. So I am starting by creating a label for the variables. I see there's a question, but I will come back to that question in a moment because I would like to progress with this first. So I am, yeah, maybe I can copy the whole syntax and I'll go through it gradually. So the first thing I'm doing is to creating the label or the factor levels for the variable that is going to contain or to record the 8 group of activities that we have seen before. So sleep and self-care, work and schooling, etc. So of course, what I'm doing here is just one way of getting the result of the temp program. There are several other ways we can do that. Second thing I'm doing, and I'm doing this uh, with this slot data set that I created earlier. So I'm actually grouping the categories or the activities into categories. So we have, for example, sleep and self-care, which is MTUS code from 1 to 7, and so on and so forth for each of the 8 activity. And then I match these to the labels I have defined earlier. I'm converting it into a factor with these 2 lines. So I can inspect the result. Okay, so that gives the number of time slots per each group of activities. Okay, so that's the first stage, data preparation, that is in the time slot data set, that is essential to uh, creating this uh, time program plot. Okay, so now just to give a broad overview of what the next lines of syntax are going to be about. So I am going to create a data frame that contains for each time slot the proportion of uh, observation or people engaged in each activity. And given that we are working with 3 different countries and I don't want to have a syntax that is too indigest, instead of having 3 times the same code repeated for each country, I am running this into a loop. So a for loop here with C, which will take the value sequentially of each country, started from Spain and finishing by the UK. And the data frame in which, or rather the matrix in which the results are going to be contained is called tmp.r. So it's a list of matrix, sorry. So, and that's the first thing. We are looping or through 3 countries. And for each countries, we are creating a second loop, which is we are looping through each time slot. Why? Because obviously it's a little bit, it would be a little bit arduous to compute manually, so to speak, or one by one, proportion of people engaged in each kind of activity at each one of the 144 time slots of a typical day. So what we do is we compute a loop in which this is done automatically or in one go for all time slots of all diaries. Okay, so that's the rationale for these two loops. All countries at the same time and or automatically looking after countries and all time slots. Then the next thing, for each one of these time slots, we are computing weighted proportions of people engaged in the activities. And by using R bind here, it simply means that to the existing state of the matrix with the result, I'm adding a new row uh, of data with the rounded proportion of each activity or categories of activity for each time slot. So for slot number I here in the loop and country C in the loop as well. So I am going to run this. And also, but that's for each, after the slots have been computed, I am adding the actual label values to make sure that it's understandable. And I'm adding also the slot number, which I call time, so that I can use them at a later stage for the plot. So this is taking a significant amount of time because we have significant number of diaries and slots. It may take even more time for if you have an older computer. You can decide to restrict this. Here it is. It's done. If your computer is struggling, you can just do it for a single country. So I'm using the reshape tool library here because I need to transform these data in order to plot them. So if you remember ggplot, or for those of you who are familiar with ggplot, it prefers working with data in long format. So there is potentially the ability of directly computing your time slot and tempogram data in long format, but I haven't explored that here. So what I'm doing in the second stage of this syntax, again, looking at each country within a loop, is to melt, so to convert this data into long format, adding a number of human readable information, such as the name of the activity column. I'm converting, and that's important because we've been working with slot number. So we want to make sure that it actually, the axis of the plot indicate time of the day. So here, these are the syntax through which I convert episode number into slot number, sorry, into human readable time of the day. And then finally, I make sure that my activity variables reflect the labels I have used before. So it's doing that inside a loop for each country. And then the last part of the syntax simply is a ggplot plot. So you need to think of it as layers. So in the first line, usually specify the data you're working with, TMPG here. the aesthetic, which is the basic parameters of your plot, and then the kind of plot you want to look at. So that's an area plot. We've seen that before. More specification for the axis here, and then theme, which is basically about what the plot is going to look like in terms of color, size of the font, etc., etc. So if I'm running this, we should, yes, I think it's here that I stopped. Where is it? Ah, here. So if I'm running this, hopefully it's going to work. Yeah. So we have, oh, so I think it did it sequentially. So that's the last one. So that's for the UK. Yeah, but it has computed the other one. So you can add a line of syntax so that it saves the data, the plot, and you can look at them separately. So I'm maybe going to revert to the slides now to show what the end result is for each country. So we are here. Was it here? Uh, no, it's the other one. Sorry. So that's yeah, yeah. Too many windows open. So we can see these three tempograms. So here it's for everyone and any day of the week, whether it's weekday or weekend. But still, there are significant differences. I maybe something that's quite interesting is that in France and to a lesser extent in Spain, people seem to spend more time on breaks than in the UK. Compare the size, the dip here into the paid work by comparison with France or Spain. The duration of or the starting time of the working day can also be different. It's not so different between France and the UK, but it's different in Spain. And again, it's things maybe some of you know from visiting this country or reading about them. Sometimes people in warmer countries sometimes start their working day earlier and finish earlier as well, and this seems to be the case of Spain, or have a longer break in the middle when the day is hotter. So that's just an illustration of the interest of tempograms and how they can be interesting, for example, for cross-country comparisons. I am aware that we are reaching through the end of the day, so I will take questions in a second, but I just want to maybe go quickly through a number of final topic. I will remain after the after 4 o'clock, so feel free to stay and ask your question then. So further topic. So I just wanted to say a few words about what are the things we can do with time diary data. And if you're a social scientist, of course, computing regression, that is modeling either the duration or the probability of engaging in activities, is something you may be interested in. And indeed, lots of researchers have already been looking at. The only thing, maybe some basic things you need to be aware of, is that the distribution of the time spent in activities differ between activities. Not all of them are normally distributed, so you need to be to take into account of that when using regression, as well as the fact that you can't just ignore the zeros. So you need to either have a model that takes into account the fact that you have sometimes many observations that are equal to zero, or to just do your model on participants. So, for example, using a selection model is a way of dealing with that. And then another thing important to consider is that if you have observations or rather, if you have several days of data per people, it means that your residuals are going to be clustered, and therefore you want to use robust standard error to make sure that your estimates are not biased. And that's even more true if you are using 7 days of data, which is sometimes the case. So here I've provided the names of two R packages that do that. So that's the first thing I wanted to mention. And the second thing I wanted to mention is that another type of analysis that has been done and that takes a little bit further what you can look at with time diary data is sequence analysis. So by sequence analysis, it's maybe something people are a little bit more familiar now with machine learning and the more computational social science approach that has been emerging in the last year is looking at how different activities or follow each other or form a pattern together. So I'm referring here to two papers that have been looking at this. And so that's Lennart Kahn that were among the first one to do that in a mainstream journal in 2011, and Vagny 2020 that has kind of updated this. And our package that allow you to do that is Traminer. It's probably not the only one, but it's one that's commonly used. And just to give you a foretaste of what can be done. So that's from Vagny 2020. So it's just basically been looking at cluster of, I think it was two, four, 10 kind of activities. And yeah, and look, in a data-driven approach, try to group them. So basically, we are looking at the distance between kind of activities, and that allows to define clusters. And it provides results that are interesting, especially and that was his core interest, the space and the scheduling of paid and unpaid work, depending on whether people were working standard hours, were working shift, or indeed unpaid work, such as childcare. I can't go into all these details, but the references provided in the last slides. Obviously, you can download this. I have also provided in the resources a number of links to more advanced visualization tools of time diary data. We have been doing here the really basics. So if you want to explore more fancy visualization tool, feel free to look at these links. So now I am aware that it's 4 o'clock, but if you have any questions, I'm more than happy to take them for as long as there will be. So I'm just looking at yes, I need to stop sharing my screen. That's what I was looking for. Okay, so I'm just looking at yes, okay, so it didn't raise your hand, okay. Okay, so I thought there was a question, but there wasn't. So feel free to ask any question. So the workshop is formally finishes formally now, but I'm going to stay online for maybe another 10 minutes. And feel free to ask anything if you have the time to stay. And of course, as Emma kindly put in the chat, please fill in your feedback sheet when you leave. That is really, really useful for us to better tailor our workshops and our content to the needs of our users. In any case, I hope you will have enjoyed this time diary data overview. Of course, there's a lot more that can be said, um, but with what we've learned over these 2 days, I think you should be able to start working on your own for irrespective of what your research interests are. One of the links I provide to the MTUS also is hosted by the Center for Time Use Research, which is one of the main research center doing time use data in the UK, which offer further training and further material. Well, stop talking now. Feel free to ask any question. There's no such thing as a silly question. So anything. Yes, there was a question from earlier. Did I observe outlier in the data? Yes, there are always outlier, like with any kind of data. You have outliers, and you need to decide what to do with it. It's partly a substantive question, depending on what your research question is, and the kind of estimates you are looking at. That's why sometimes I prefer working with median rather than mean duration. Okay, doesn't seem to be any questions, so I will just thank you again for taking part to this workshop. It was really a pleasure to present this content today and last week, and I hope you have enjoyed it as well. And we will be running it again probably next year. Thank you.
Thanks, Pierre.